Hello students, we are going to continue with 4th unit with its 5th topic, that is concurrency control. First of all, we must know what is concurrency and how to control it. In a multi-programming environment where multiple transactions can be executed simultaneously, it is highly important to control the concurrency of transactions. We have concurrency control protocols to ensure atomicity, isolation, and serializability of concurrent transactions. Concurrency control protocols can be broadly divided into two categories. The two categories are: first is lock-based protocol and second is timestamp-based protocol. Now, first of all, we will learn about lock-based protocol. Locking technique for concurrency contains some of the main techniques used to control concurrent execution of transactions are based on the concept of locking a data item. Now, what is a lock here? A lock is a variable associated with the data item that describes the status of the item with respect to possible operations that can be applied to it. The lock is used to synchronize the access to the data item. Locks are of two types. First is binary locks and second is shared or exclusive locks. Now, what is a binary lock? A binary lock on a data item can be in two states. It is either locked or unlocked. Now, what is a shared or exclusive lock? This type of locking mechanism differentiates the locks based on their users. If a lock is acquired on a data item to perform a write operation, it is an exclusive lock, allowing more than one transaction to write on the same data item would lead the database into an inconsistent state. Read locks are shared because no data value is being changed. Now coming to the next topic, that is two-phase locking. This locking protocol divides the execution phase of a transaction into three parts. In the first part, when the transaction starts executing, it seeks the permission for the locks it requires. The second part is where the transaction acquires all the locks. As soon as the transaction releases its first lock, third phase starts. In the third phase, the transaction cannot demand any new locks. It is only releases the acquired locks. The two-phase locking has two phases. First is the growing phase, where all the locks are being acquired by the transaction, and the second phase is the shrinking phase, where the locks held by the transaction are being released. Two-phase locking guarantees the serializability of schedule without the need of testing it. Two-phase locking protocol guarantees the serializability of schedule without the need of testing it. Two-phase locking limits the concurrency by early locking all the items even it may not need all of them early, and by delaying unlocking all the items until locking all the items is needs even it may not need the locked item. The algorithm is called the basic two-phase locking, and there are many variations to it. Now moving to the next subtopic, that is deadlock. Now what is a deadlock? In a multi-process system, deadlock is an unwanted situation that arises in a shared resource environment where a process indefinitely waits for a resource that is held by another process. There are three solutions to deadlock. First is deadlock prevention protocol, second is deadlock detection protocol, and third is timeouts. Now talking about the deadlock prevention protocol, there are two schemes to prevent a deadlock. First is wait die and second is wound wait. Talking about wait die, in this scheme, if transaction Ti is less than transaction Tj, that is, Ti, which is requesting a conflicting lock, is older than Tj, then Ti is allowed to wait until the data item is available. Second possibility is if Ti is younger than Tj, then Ti dies. Ti is restarted later with a random delay but with the same timestamp. This scheme allows the older transaction to wait but kills the younger one. Second scheme is wound wait scheme. In this scheme, if a transaction requests to lock a resource which is already held with conflicting lock by another transaction, one of the two possibilities may occur. If Ti is less than Tj, then Ti forces Tj to be rolled back, that is, Ti wounds Tj. Tj is restarted later with a random delay but with the same timestamp. Second possibility is if Ti is greater than Tj, then Ti is forced to wait until the resource is available. Now moving to the deadlock detection protocol, the concept is to not enforce any restrictions on executing the transactions but check if a deadlock actually exists. For this, we are having wait for graph. Wait for graph is a simple way to detect the state of deadlock. It is used to check the existing of a deadlock. If a graph has a cycle, the state of the deadlock exists. The system must abort some of the transactions when a deadlock has been detected. Selecting a transaction to be aborted is known as victim selection. The algorithm of victim selection should avoid selecting transactions that have been running for a long time and that have performed many updates. Now moving to the last solution of deadlock, that is timeouts. It is simple and practical due to its low overhead. The idea is to have a system-defined timeout period and a mechanism to abort the transaction that waits for a period longer than the predefined timeout. The system assumes that the transaction expired, the timeout may be in a deadlock. Now, next term to know when we are learning about deadlock is starvation. The problem occurs when a transaction cannot proceed for an indefinite period of time while other transactions in the system continue normally. It may occur if the waiting scheme for logged item is unfair. The solution for this is using of a fair waiting scheme as first come first serve, allowing priorities for transactions but increase the priority of a transaction the longer it waits until it eventually gets the highest priority and proceeds. Now moving to the last subtopic of this topic, that is timestamps. Timestamp concurrency control protocol using the timestamps to order the execution of a transaction for an equivalent serial schedule to guarantee serializability. While defining the timestamp, timestamp is a unique identifier created by DBMS to identify the transaction. The timestamp values are assigned in order in which the transactions are submitted to the system. The timestamps can be generated by using a counter that is incremented each time its value is assigned to a transaction or by using the current value of date time value of system clock. It is important to note that the timestamp concurrency protocol are deadlock free because there is no lock. Thanks for hearing me. I hope you understand this lecture.